This is a demonstration of the X-Way API Management 762 Externally Managed Topology, or EMT. We started this demonstration with showing the nodes that we have created to configure our cluster. So we have 3 nodes, master and 2 workers, but we control allocation of some of the pods on master node 2 just for ease of demonstration. In order to deploy the entire API management configuration, we use Helm charts. So Helm is a package manager that allows you to more easily control the entire configuration of, in our case, X-Way API management. So we created some charts and we control execution of those charts with one of the files that has some custom values that we can change before we execute Helm commands. So let us quickly review those charts. So I'm sorry, local files. So as you can see, we have multiple type of components that we are going to create: admin node manager, API management, UI, port 8075, runtime, API manager, and some other like MySQL and some other components. So as of now, we are going to instantiate admin node manager, API manager, UI, but not the runtime. So in order to do that, we are going to execute like a script that has some built-in Helm command, and I can quickly show you that file. So it executes Helm install command and passes some of the values that we provide as input to the script. So let's run this script. It will ask you for my username and password to authenticate to Docker registry from where we get Docker images. And then it executes this Helm chart. For convenience of showing all the components in this cluster, I'm going to switch to our namespace where all of those components are running. It's called demo. And now if we execute get pods command, we see that we have admin node manager pod, which is already running, API management UI interface port 8075, and some MySQL database, as well as this is an ingress controller that allows us to access from outside of this cluster components that's running in our cluster, namely admin node manager, API manager UI, and the runtime. I also want to show you that we already have several services running. And those services, admin node manager, port 8090, API manager, UI, port 8075, and some other components. We have Cassandra running outside of the cluster, but we created an external service with this IP address. So Cassandra is running outside of this Kubernetes cluster. Just to show a flexibility of working with Helm charts and modifying on the fly the configuration, I will change some of the parameters in the local values file, and I will enable API manager runtime switching from false to true. There are, of course, multiple ways of doing the same stuff, but I want to demonstrate different ways of doing that. So if I run an upgrade script, and again, it's a wrapper around Helm upgrade command. So let me show you that upgrade script. So there are a couple of variations I can run with this script, but basically it's a Helm upgrade command, and I'm passing the local values file. So upgrade cluster, and again, I need to provide my user ID and password for the registry. And I'm going to say that, yes, please use the local values file for this Helm upgrade command. So now if I will review what pods are created, you see that now I have API Manager pod created, and if I look at the services, I see the API Manager service that exposes 3 ports, 8065, and a couple more. Okay, so now our cluster is pretty much as what we would expect for API management configuration, but how do we actually access those components from outside of this cluster? As I mentioned, we have an ingress controller. So if I display ingress settings, I have the following hosts defined. So admin node manager, API management. So just for demonstration purposes, I'm going to open the admin node manager interface. And admin node manager has less responsibilities in this EMT topology. It's not actually controlling or deploying configuration to the gateway managers or gateways. It's just more of a monitoring, displaying component. So we see 2 instances running, one for admin API Manager UI and another one for the runtime. And if we go and execute like a health check request just to verify, yep, it comes back. Okay, so our configuration working, and we can access our APIs from outside of this cluster. The next thing that is very nice with new EMT topology is that we can easily scale this configuration. With the classical mode, it's not that easy, and there is delays in implementing the scaling capabilities. But with EMT topology running under Kubernetes, it's really easy. And so right now, just for demonstration, I will display all the instances of a pod, and right now we have just API Manager one pod running. So let's scale it to 2, and we scale stateful set called API Manager, and we change replicas to 2. So if we now display pods, now we see the second pod created immediately. And again, in this demonstration, I already ran this several times, so all the images have been downloaded on this node. And if I display the local values file, I'm using the if not present kind of image usage policy, which means if the Docker image is not present on the node where it's scheduled, then Kubernetes will go and grab this image from the registry. But if it's present, it's not going to update it. And again, this is more for flexibility and ease of demonstration. So we have 2 instances of API Manager running. And I'm going to run a simple load test, going for a health check endpoint for some time to generate the traffic, and then going to API manager and seeing that, yes, traffic is coming to gateways. And if I look at the monitoring, there is kind of showing 0 API manager 0, but and if I go to the traffic monitor and I look at the traffic and I look at different servers, I can see that the traffic is split between both servers.